Hello everyone. Today we have came up with again the general anesthesia chapter with the structural and synthesis part of the chapter. Here we will concentrate on the few synthetical part of some few compounds. The last part of the video, the last part of the theory we have known that the general anesthetics can be divided into three groups, basically on the mode of administration. They are inhalation anesthetics, intravenous anesthetics, and basal anesthetics. So here we have taken into account the inhalation anesthetics, which are either volatile liquids or gases, and they are administered through the inhalation process. So first thing which we'll take into account is the ether. It is prepared by the interaction of alcohol and sulfuric acid. It's a one method at a temperature of 130 to 137 degrees centigrade, which we basically call as a etherifying temperature. It goes to form an intermediate when it's being reacted with ethanol and H2SO4 sulfuric acid, that ethyl sulfuric acid intermediate, which undergoes further reaction with the ethyl alcohol to keep the ether. The second method can be also being prepared the ether from ethylene, which is reacted with H2SO4 sulfuric acid to form the intermediate complex, and then again it has been reacted with ethanol to form the ether. It still continues to be as an use in anesthetics, but nowadays it has been not being used much because it has some alteration in the metabolic processes of the body. Dose by inhalations as required. Then we come to the ethyl chloride. Ethyl chloride is prepared conveniently by distilling together a mixture of alcohol, sodium chloride, and sulfuric acid. It can be also being used as a local anesthetic by freezing. But nowadays, it is not used much because it has an serious disturbances with the cardiac rhythm. So now take into account the vinyl ether, the third compound. It is prepared by treating ethylene chlorohydrin with sulfuric acid to form an intermediate of 2,2-dichloroethyl ether, 2,2-dichloroethyl ether, with subsequent treatment with ethanol and potassium hydroxide gives a vinyl ether. It is being used versatilely and it is much more potent than ether, and it has a longer duration of action, but it has a serious risk of liver necrosis, which must be taken into account that it is much more potent than ether, 4 times potent than ether, but it is a risk of liver necrosis. The third one, chloropropane. It is prepared by the action of zinc or any other metal like sodium and magnesium on 1,3-dichloropropane. Chloropropane is the most potent anesthetic administered by inhalation with the help of brass regulator. It is also being doses by inhalation as required. Fluoroxene is another compound which goes on addition reaction of 2,2-trifluoroethanol with acetate in presence of some basic catalyst under pressure, which is given the desired product. It is also being frequently used for the first or upper second phase of anesthesia. Its dose is also being mentioned by inhalation as required. Then we come to account the halothane. The halothane is being prepared by bromination of 2-chloro-111 trifluoroethane. On bromination basically yields a halothane. It is being also being a safe, potent, volatile anesthetic administered by inhalation. It may produce any depth of anesthesia without causing hypoxia. It is very important. It doesn't produce any hypoxia. Now, methoxyfluorine is another compound. It is also most potent anesthetic agent which is being used today nowadays. Trichloroethane, we have given here the synthesis procedure. We take help the catalyst as lime from the simp tetrachloroethane to get our desired product of trichloroethylene. Now, we will take into account the nitrous oxide, which is popularly known as a laughing gas. It has been prepared by heating ammonium nitrate up to 200 degrees centigrade to produce the nitrous oxide and corresponding 2 molecule of water. It is weakest but safest inhalation general anesthetic. It is usually administered with other potent inhalation anesthetic like fluoroxine, halothane, etc. The most commonly used one is chloroform. We all knows that it is being used for anesthesia. A series of reaction undergoing the process to produce chloroform. We take the first starting material as bleaching powder, which can be converted to slackened lime, and then reacted with ethanol to produce the acetaldehyde, then the trichloroacetaldehyde, which finally gives the chloroform. It is being prepared from the bleaching powder, a series of reactions to produce the corresponding desired product. It is a potent anesthetic administered by inhalation. It has both reasonably good muscle relaxant and analgesic property. It is no longer used because of its liver and kidney toxicity. This is all about the synthetic procedure of general anesthetics. I have taken the help of Ashutosh Kaur Medicinal Chemistry to complete the video. Thank you for watching.